solve t of n minus 1 plus n where n greater than 0, and if n is equal to 0, the value is equal to 1. We know our t of n is equal to t of n minus 1 plus n. This is a recurrence relation. Let us see how to solve this recurrence relation using recursion tree method. To solve this recurrence relation using recursion tree method, first we will construct a recursion tree, and using that recursion tree we will solve this recurrence relation. For constructing a recurrence tree, first I am writing t of n here, and this is t of n, and t of n is equal to t of n minus 1 plus n, and we know t of n is a recurrence relation. And how many times this t of n is executing? We can say t of n is executing n times. And how many times this t of n will call itself? I can say t of n will recursively call itself t of n minus time. Then consider this t of n minus 1. How many times this t of n minus 1 will execute? This t of n minus 1 will execute t of n minus 1 times, and this will recursively call itself t of n minus 2 times. And what about this t of n minus 2? This t of n minus 2 will recursively call itself execute n minus 2 times and recursively call itself t of n minus 3 times. And if I am continuing like this, where will this stop? It will stop when the value of n is equal to 0. Okay, so here I am writing t of 2, and what is this t of 2? It will execute 2 times and recursively calling itself 1 times. What about this 1? It will execute 1 time and recursively calling 0 time, and here this algorithm exit. Okay. Observe this t of n. First t of n, then t of n minus 1, t of n minus 2, t of n minus 3, etc., etc., t of 2, 1, 0. Okay, from this recursion tree, I can say that the value of t of n is reducing by 1 in each step. First t of n, then t of n minus 1, t of n minus 2, t of n minus 3, etc., 2, 1, 0. Okay, the value of t of n is reducing by 1 in every step. Then let us see how to calculate or how to solve this recurrence relation using this recursion tree. For that, I am calculating the time complexity in each step. So first of all, I am considering the value of considering t of n. So how many time taken to execute this t of n? I can say it will take n times. And what about this t of n minus 1? I can say it will take n minus 1 times. And what about this t of n minus 2? I can say it will take n minus 2 times to execute, and in the case of t of n minus 3, it will take n minus 3 times to execute, and for 2 it will take 2 times, and for 1 it will take 1 time. Okay, now I know the time complexity of each step. Then how can I calculate the time complexity of this whole algorithm? For that, I am just adding all these terms. Okay, then I can write this as t of n is equal to 1 plus 2 plus n minus 1 plus 2 plus etc. plus n minus 3 plus n minus 2 plus n minus 1 plus n. I am writing the time complexities from bottom to top. 1, 2, etc., n minus 3 plus n minus 2 plus n minus 1 plus n. I am adding the time complexities together, and we will get the time complexity of the entire algorithm. Okay, then I can write t of n is equal to, see, what is this equation? This is 1 plus 2 plus etc. plus n minus 3 plus n minus 2 plus n minus 1 plus n. This is sum of n natural numbers. This is a sum of n natural numbers, and I can write the sum of n natural numbers as n into n plus 1 by 2. This is our time complexity. T of n is equal to n into n plus 1 by 2, and I can say the time complexity of this T of n minus 1 plus 1 n minus 1 plus n is equal to big O of n square.